ask you, yes,
Uh-huh.
we're solving like the exercises, like the last one, number 10. It was a bit confusing. I tried to solve it yesterday in the evening, but I couldn't really get it.
Where a differentiability and continuity?
Uh, no, like the exercise number 10, like let f be from R to R, be the function defined by,
No, no,
we have to find,
we need, yeah, we need to consider here a differentiability and the continuity of the
yeah,
function
yeah,
f of x. Yes.
yeah, yes.
Okay. So now let's again switch on this demonstration. Okay, just a moment. But but I don't have here. Sorry. So but can you demonstrate it, or do you have it?
I can send it to like the group.
Okay, okay. Let do it. So just me share. Okay, right board, and here we'll do the exercise. So I need only f of x. F of x, it's
Uh, I sent it.
you don't remember? Ah, okay, okay. Ah, yes, okay. So x minus b,
Square minus
x
2.
minus b square minus 2, if
Keep
x
x.
less than 0, and a sine x plus 2x if it's greater than or equals to 0. This one, yes? So, and we need to consider here continuity of the function and differentiability of the function. First of all, let's start with continuity. So, when it is continuous, if right side limit equals to left side limit, yes? So here, in this case, 0 minus should be equals to 0 plus. Is it clear? So, and what does it mean 0 minus and 0 plus here? So 0 minus and 0 plus here. So 0 minus, we need to consider the first one. If 0 plus, here it is the second one. Okay? This is 0 plus, this is minus 0. So, and now, let's start finding limits here. Limit as x tends to minus 0 or 0 minus, you can denote with 0 minus or minus 0 just. So you need to consider the first side, first part of this function, and you will put just 0 instead of x. So it will be now b squared minus 2. Yes? Is it clear, Delnura?
Yeah, it is.
And now, so the next one here is it's just b squared minus 2 because it's not depends on the x now. So, and now let next one is here's limit as x tends to 0 plus, so f of x, it will be now, instead of x on the second part, here you need to put again 0, so it will be just 0, yes? Because of here, sine x, x as x tends to 0, it will be just 0, 2x, it's again 0, so it will be just 0. So now we are equating these two ones, b squared minus 2 equals to 0, hence b squared equals to 2. So this is the first part. And now, we need to do the same work with derivatives, one-sided derivatives now. Do you understand me?
Yeah.
So here, the
Mm-hmm.
first side of derivatives will be f prime x here. Just do the separately derivatives here. It will be 2 with respect to x, of course. X minus b. Yes, 2x minus b, and there was just 1 multiplied. And next one here is where x less than 0. And next one here is a cosine x plus 2. Yeah, where x greater than or equals to 0. And now again, define here limits, one-sided limits of these functions, two functions now. When you do here left side limit, so it will be 2, you put just 0, yes? Minus 2b should be equals to, when you put here 0, it will be now cosine 0 is 1, so a plus 2. Is it clear? How can we obtain this one? Elnura, do you hear me?
You mean obtain what?
So here we just find again limits as x tends to 0 and equating again. So which means that one-sided derivative f prime minus should be equals to f prime plus. So left side derivative should be equals to right side derivative. So here put to the first in f prime x, put instead of x 0, it will be minus 2b, yes? And put similarly in the second part a cosine x plus 2 instead of x 0, it will be a plus 2. Now here we have two equations, this one and this one, simultaneous of equation. So here we can find b, it is square root of 2, and put to the second equation and get a. Because of here, that's why here written where b is positive, so we need to consider only b equals to square root of 2. And if you put here square root of 2 instead of b, it will be a equals to, so minus 2 square root of 2 minus 2. This one. So the correct answer here is D1. Is it clear? If something is not clear, please ask. Alnura, is it clear? So this is defining the continuity first of all.
Yes, sorry, I had a bad network connection. But yeah, it is clear. Thank you.
Now clear, yes, this one. So here you must to consider firstly continuity. Let me repeat one more time. And differentiability. To check continuity, you will check one-sided limits, equating one-sided limits. To check differentiability, you need to you must to equating one-sided derivatives. Okay.
Yeah, okay. I had a bad network connection, so I couldn't answer.
Another question, even?
No, it's fine. Thank you.
Okay. Okay. Any other questions, students? You can take a photo of this one or save or use just do screen shoot. Okay, so now Let's, if you have no questions, other questions, we can just move to some versions. So let's start new version if no questions. So just a moment. Is it visible?
Yes, it is.
Okay, I want to show some examples here. For example, this kind of find incorrect statement. Not this one. I think this one is not. This one is okay, but here are some troubles we have. For example, let's start with improper integral here. This one. Question number 1. Decide which one of the following is correct. So, how to find here the result? So, is it converts or diverges?
It converges
Why?
because the greatest cover is 2.
Uh-huh. Yeah, we can just estimate it. Estimate. So this 1 over x squared plus x minus 2 less than or equals to 1 over x squared, yes? That's why here, this 1 over x squared, this integral converges using comparison theorem. The given one also converges. But now we can solve this integral. Yes, how to solve it? Because here we have versions. The integral converts to 1 over 3 natural logarithm of 2, square root of 2 over 3 natural logarithm of 2, and others. So the C1 is not correct and E1 is not correct here. So from these three ones, A, B, D, we need to find correct answer. So to define here correct answer, firstly, solve this example. So here we have limit as we need to move to the limit, yes, from this one. Limit as t tends to plus infinity from 2 till t dx divided by, so we can just factor out here x 2 and minus 2 and 1 here. The roots are x plus 2, x minus 1. Yeah. And now solve this integral, then move to the limit. Is it clear? And how to solve, you know, using decomposition of the fractions. So it will be 1 over x plus 2, x minus 1, which is equals to a over x plus 2 plus b over x minus 1. Yeah. And find unknown coefficients here, a and b. So to find a and b, what should we do? Who knows? Simur?
We need to give a common denominator and
Uh-huh.
equal it to.
Yeah, equating to the 1, correct. But we can do this, since it is a linear one, so we can use a very useful method. Just close the, for example, in the first case, just close the x plus 2 and put minus 2. So here, what we get here, if you do it, if you put -2 instead of x, it will be -3. So a, since a equals to 1 over -1/3. And similarly, you will close x minus 1 and put 1 instead of x. So it will be 1/3. So here, b will be 1/3. You can check. Put instead of a -1/3 and instead of b +1/3, and then you get the same answer. So here we have now -1/3. So it will be now equals to limit as t tends to +∞ to t. So it's not. It's not possible here to write. So let me write here. Limit t tends to +∞. So to t. Then here we have -1/3 x plus 2 plus 1/3 x minus 1 dx, and then solve it. So you get here, if you factor out 1/3, it will be now sorry. So here we have now limit as t tends to +∞. T tends to +∞. What do we get here now? Natural logarithm, yes. 1/3 natural logarithm x minus 1 divided by x plus 2, and put here 2 and +∞. 2 and t, sorry, not +∞, t firstly, and then you will solve here, find here corresponding value and put +∞. Is it clear? I think here no problem now. Just putting t, it will be 1/3 natural logarithm t minus 1 over t plus 2. And if you put 2 here, it will be 1/3 natural logarithm 1/3. Okay, let's consider next one now. And the correct answer here is D1. Next one now. You can take a photo again, this one. May I clear?
Yes.
Okay. So now, next, find the value of the integral. How to find it? Number 3 is here almost same with the previous one, yeah? We can do together now again, this one. So find the value of the integral. There shouldn't be some problems because of its just integration by parts. First of all, of course, you need to continue it like from minus pi over 2, 0, and x times sine squared reducing to power. It will be 1 minus cosine 2x divided by 2 dx. Yes? And then you have two integrals. Integral from minus pi over 2, 0. So x over 2 and minus dx minus integral from minus pi over 2 till 0. So this one now, x 1 over 2 also we have here. X, you can see here, x cosine 2x dx. Yeah, here we have two integrals. And now solve this one. The first one is very easy. The second one is here just using integration by parts. You denote u as x, cosine x 2x dx will be dv. And what was the formal integration by parts? U dv equals to uv minus v du. So, and here v is equals to 1 over 2 sine 2x. That's it. You just put again. If it is AB, of course, it will be, if it is definite integral, it will be AB. Here again, AB. Is it clear? Second one? And you can get the result here. Any questions? So after 3 minutes, this session will close it again and you need to rejoin to this session. Any questions here? Number 2. Now can you continue it? Okay, okay. So number 3 now, let f be the function, the same with the previous one. So let's, and here only continuity here, only continuity. Here only continuity. We don't have here differentiability. So f be real, if be function, real valid function, definite on this, by this part. So it is piecewise function again. And what should we do here now, Danura?
We need to find limits.
Yes.
One-sided limits.
One-sided limits at the point 0 and at the point 1.
Yes.
So left side limit at the point 0, it will be now, just put instead of x 0, it will be 2b minus 2. Yes? It's very easy now. 2b yes. minus 2 should be equals to right side limit at the point 0. It will be at here 0, 0 minus 1, 1 square. It is just a plus b. So, and similarly, once one-sided limit is a point 1. So here it is now. When it is 1, it will be now, instead of x, you put 1 here. It will be 0. It will be just b. B should be equals to, the third one here is 3a plus 1. So just find here now corresponding values a and b. If the system has the solution, it means that it is continuous. It's continuous at the both points 0 and 1. And here I think it's satisfied. And A is here 0.1 and B here is 2.5. D is correct. Yes. Is it clear? Number 3?
Yes. Yes.
Yeah. There are no difficulties, I think.